NAT lets you share one internet connection with many devices. Most people don't realize it, but one of the biggest tricks behind your home internet working smoothly is something called NAT, Network Address Translation. Let's break down what it is, how it works, and the different types used in networks today. The problem NAT solves: you have multiple devices at home, your laptop, phone, tablet, smart TV, all connected to the internet. But your internet service provider, ISP, only gives you one public IP address. So how can all your devices browse the web, stream video, or use apps at the same time? That's where NAT comes in. What is NAT, Network Address Translation? NAT is a feature built into your home router that acts like a smart middleman between your private devices and the public internet. Here's what happens step by step. 1. Your device, e.g. phone, makes a request to open a website like example.com. 2. Your router receives that request and replaces the private IP address of your phone, e.g. 192.168.10, with its public IP address, e.g. 104.58.92.1. 3. The router keeps a translation table that records which device made the request, what internal IP it used, and what port number. 4. When the response from example.com comes back, the router checks the translation table and forwards the reply to the correct device. This all happens in milliseconds, and it works silently in the background. Real-world analogy. NAT as a receptionist. Think of NAT like a receptionist in a company. The company has one public phone number, your public IP. Each employee, your devices, has an internal extension, private IP. When someone calls in a response from a website, the receptionist checks who the message is for, translation table, and transfers the call to the correct extension. Without NAT, every employee would need their own external phone line, expensive and impractical. Why do we need NAT? There are two main reasons NAT became necessary. 1. IPv4 exhaustion. There are only about 4.3 billion IPv4 addresses. That's not on every phone, laptop, or IoT device in the world to have its own. 2. Security. Devices behind NAT are not directly exposed to the internet. That adds a layer of protection against direct attacks. Types of NAT. There isn't just one way NAT works. There are three main types. 1. Static NAT, one-to-one mapping. A specific private IP is permanently mapped to a specific public IP, mostly used when a device needs to be accessible from outside, like a web server or CCTV system. Example, 192.160.1, 203.113.10. Pros: predictable and consistent. Cons: not scalable. You need one public IP for each device. 2. Dynamic NAT, many-to-many mapping. Devices are assigned a public IP from a pool of available IPs. The mapping is temporary, used only during the session. Example, 10 devices inside the network. ISP gives you 3 public IPs. Only 3 devices can access the internet at once. Pros: more efficient than static NAT. Cons: still limited by the number of public IPs in the pool. 3. PAT, port address translation, many-to-one mapping. This is the most widely used and most efficient form of NAT, also called NAT overload. PAT allows hundreds of devices to use the same public IP by mapping each session to a unique port number. Example, 192.168.110.50,000, 104.58.92.1 3456, 192.168.111 52001, 104.58.92.1 3457. The router keeps track of who requested forwards responses back to the correct internal device. Pros: allows unlimited internal devices to access the internet with one IP. Saves public IP space. Works for most home and business needs. Cons: not ideal for hosting internal servers. Can break some peer-to-peer applications without special configurations. Bonus: NAT and Security NAT doesn't just solve the IP shortage, it adds a layer of security. Devices on your private network aren't directly reachable from the internet. If someone tries to connect to your public IP, the router won't forward the request unless you explicitly set up port forwarding, or a DMZ. Think of it as a built-in firewall. NAT and IPv6 still needed? With IPv6, there are enough addresses for every grain of sand on Earth. So do we still need NAT? Not in theory, but in practice, NAT is still used. for security, for backward compatibility, in hybrid networks, IPv4 plus IPv6. Conclusion: NAT is one of the hidden engines behind modern networking. Without it, you'd need to buy a public IP for every single device. Home networks wouldn't be affordable or scalable. The internet would have run out of IPs long ago. And thanks to port address translation, your single home router handles everything, giving every device in your house seamless access to the web.